Here's tired light. We're comparing the angular separation between galaxies in a cluster as a distance measurement, and here their redshift of the cluster. Tired light model, and here expanding universe model, you see it's too far up at the high redshift end. We were hoping to get some data with the Hubble telescope, but they couldn't, as you hear, focus the mirror properly, so we have to wait another 3 years. Here's another test. This is the galaxy number count test to count the number of galaxies you see in a certain region versus their magnitude, which gives you a distance measurement. And here's tired light model closer to the data points as compared with expanding universe model. Then even looking at radio galaxies and looking at their radio emission, here's the data, this hatched region. Here's the tired light model. Here's the expanding universe model. Okay, so the universe, according to subquantum kinetics, is static. It's not expanding. Therefore, you don't need a Big Bang. Small is beautiful. And another prediction is in the supercritical regions you'll get this energy amplification taking place. Therefore, you would expect that, okay, it turns out that the amount you propose is so small you can't measure it in the laboratory. In fact, to explain all the energy that the sun is radiating, all you need in terms of the amount, you think of it as money in the bank that's collecting interest, okay? The amount of the sun's heat reservoir would be like the capital, and the amplification on each photon, each dollar in bank, would be like the interest. And the amplification rate is so small it would be 100 million times smaller than what you can measure in the laboratory with the best instruments. So the only place that this could become apparent is at astrophysical levels. So that's why I say this aspect of subquantum kinetics is tested in the cosmological arena. One suggestion then is that maybe a part of the sun's energy is due to what I call genic energy. This is the name I've come up with. I call this genic, meaning spontaneously generated. And again, it's a form of free energy. It's different from the zero-point concept. But again, it's a form of free energy. So what I did, I found that you can plot the mass against the luminosity of the star. This is a standard diagram in astronomy. It's called the mass luminosity diagram. And they find that stars go according to what's called a mass luminosity relation. As they go up in mass, their luminosity follows a line. And this is the line that you predict by subquantum kinetics. Now there's a certain amount of error in that. This is the average of the line, but it's interesting that the average fits very, very nicely. The other thing, I've drawn this so that it actually matches the trend, but the actual average comes out to within a few percent of this. If you extend this downward and you plot also the heavy planets, notice they found that the heavy planets have internal heat sources. In other words, they radiate more energy than they receive from the sun. And actually, this occurred to me, well, if this is true in stars, then it means that we should find something in planets. I did some research. Sure enough, Jupiter they had found this was in the early days, back in 1978 when they were just finding this. Sure enough, I was thrilled to find that Jupiter had a heat source, and later they found Saturn and so on. And as you see, they also line up. Then if you extend this up to the sun, you find, the sun is on a different trend line. Actually, the trend line takes an upward bend to a steeper slope. Instead of being a 2.75 power slope, it's a 4.0 slope. And that happens right about 45% of the sun's mass that you get the steeper slope. This is called the upper main sequence, where the sun is. And this is the lower main sequence, where these called red dwarfs are. Well, when you project this line up, it predicts about 2/3 of the sun's energy, which is very interesting because they can only account for 1/3 of the sun's energy in terms of the solar neutrino experiments. So this resolves what's long-standing called the mystery of the missing solar neutrinos. Now, there's also what's called the luminosity function. This is where you plot the number of stars in a certain luminosity category versus their luminosity, and you get this distribution. And as you see from this, most of the stars are in this lower main sequence, which I'm suggesting is totally run by genic energy. By the way, this reminds me, in that diagram, the fact that the planets and lower main sequence stars lie on the same relation is a very serious thing for fusion energy. Why, if it's not due to but just chance, it means that whatever's happening in the planets is also happening in the stars. So that rules out nuclear, because we know nuclear can't be fired up in Jupiter. It's just the temperature's too low. And we know that if it's just primordial heat, like they suggest for Jupiter and Saturn and so on, it can't be what's happening in the stars, because they would have fizzled out millions of years ago. So there's some sort of ongoing generation-free energy that's linking these two. Now, what I'm suggesting is that all of these stars are basically run by pure genic energy. And right here, where you get this bimodal, it's very interesting. Right here, where that relation takes a steeper slope, you get a new distribution coming. And I'm suggesting this is where fusion energy kicks in. So these stars have a mixture of fusion and genic. And it's interesting that most of the stars are genic powered, 90%. Although these are actually account for the lion's share of the light you see. Well, if we were to put, here's a listing of various kinds of energies. I'm suggesting genic energy is one of them. It's actually the most commonplace, natural type of free energy, and that's what runs the universe. So what we talk about subquantum fluctuations, which you mentioned here a lot, zero-point energy, could be considered another. And it's sort of related to this as far as the matter creation goes. Then there's electromagnetic field extraction type of energy that a lot of times with these solid state transformers they claim are producing more energy than they use up. This could be due to the fact that we are moving relative to the ether frame at 378 kilometers per second. Now you see, in relativity theory, we're stationary, so there shouldn't be any energy possible to extract. But if we in our fields are moving relative to an absolute reference frame, then this implies a whole new restructuring, rethinking of field theory, and maybe what these machines are doing is extracting energy from our motion relative to the ether. And then there's also the possibility that if you can actually modify the gravity field, you can produce, instead of a see, the Earth has a diversion field, whereas if you could produce a curl field, one that folded back on itself, you could generate energy in unlimited amounts. In other words, if gravity always pulls in a circle, then all you have to do is put a pinwheel in the center, like a paddle wheel, and it spins infinitely. And actually, Brown did this experiment in 1958. He had to shut the power down because the wheel was ready to fly apart. So this is another source of energy. Well, we don't have time. I could go in and show you. I've got a list of 27 points where, on one hand, is a problem in physics, and the right hand, how it's solved with subquantum kinetics. But I won't go into that. Any questions? Yeah.
Did Brown do those experiments in Paris? Was that his?
Yeah.
Okay.
Yeah.
You didn't say very much about magnetic.
Oh, I missed that. Okay, magnetic fields. Okay. Okay, in subquantum kinetics, a moving electrostatic potential is what creates your magnetic field. There is no magnetic potential. This is one thing that's different from a lot of what you're hearing from other people. They're suggesting there's a magnetic potential. In subquantum kinetics, you don't have that. All I'm saying is that magnetic forces are due to an electrostatic potential moving relative to that charge. In other words, that when you have think of this like a water going down a well, like the X being drawn in. If you move that, you not only do you create a longitudinal wave, but you have a transverse component to it. And if you study it, you have not only divergences, but curl products. And it's those curl products that create the magnetic force in that theory.
I'm wondering where you're denying there is relativity theory.
Yes.
And relativity theory has had many successes, like even you adopted one on the redshift, and that's a really general relativity result.
No, that's Doppler. The standard view, the expanding universe version is that's a Doppler shift.
Well,
The tired light model has nothing to do with.
No, that's not true. Actually,
Wait a minute.
General theory says that when the potential is lower,
Yeah.
that there will be a blue shift.
Okay.
When the potential is higher, you'll have a redshift.
That's called the gravitational redshift.
What you had.
No, that's the gravitational redshift. I wasn't talking about that. That's the reason why certain white dwarfs have their lines redshifted.
Well, that's a minor.
That's a different thing, and subquantum kinetics predicts a gravitational redshift. Okay.
What I wanted to say is that relativity theory has had so many successes, and to just throw it out through the window like that in favor of something that you have based on speculations that somebody might think are not well founded, to me it looks like not a good deal, really.
If I was talking to a systems audience, they would understand everything I said. This is firmly grounded in systems theory. There's nothing speculative about it. Okay, this is chemical kinetics. Yeah, that's a whole field of science.
Well,
It's based on this.
The chemistry
And what you're contesting is not my theory, but the question of whether there is an ether. And I'm saying that Silvertooth's experiments have shown that there is an absolute reference frame, and that tosses special relativity out. Yeah.
I was wondering if Silvertooth's experiments have been repeated by others, or is he the only person who detected?
Okay, so far they haven't. He used a very expensive photomultiplier tube where he took a TV tube and cut off the end so that the laser beam could actually pass through it and illuminate the photosensitive surface. And something like that, you're talking about an investment of $50,000. He had some friends at GE that produced the tubes for him. So that's been an impediment for people to reproduce his experiments. So as far as I know, no one has reproduced the experiment and said it's wrong. Now, before this is true, before the scientific community is going to accept what he did, they're going to wait for other people to reproduce. Now, this is the case with all situations. Now, I've personally met Silvertooth. I've read his papers carefully, gone through the whole thing, and observed that his result checks with the anisotropy very closely, the dipole microwave, and suggest to you and letting you in on something before it hits the newspapers. The rest who want to be more skeptical, fine.
Could you give us the references where we can read about your...
Yeah, this is for sale for something like $17 in the bookstore.
What's the name of it?
It's the General Systems, the blue book, the International Journal of General Systems, which notice it was published in a systems journal and not a physics journal.
Okay, you're forgiven.
There's also there's another paper, that the Astrophysical Journal paper on the cosmological redshift is also out there.
Does your theory explain the Einstein effects? For example, the orbit of Mercury precesses.
Yeah, that's a mass change effect in this physics. Mass increases. If you have two stars and they get closer together, their mass actually increases. I don't want to take up any more time from Panos. I just wanted to mention, I just remembered, a critical thing I forgot to say was that I talked about dipole motion, but I didn't talk about if you have a monopole antenna.